to describe what the is-a relationship is for following different types of things in games. And specifically, the is-a relationship means, hey, can you put this word in front of another word? Is a sword a weapon, right? And you can say, yes, a sword is a weapon, right? So I asked you to essentially write up a relationship between these things. So in this case here, I'm just going to paste all these. So the way I did this before was I would draw out like the hierarchy here. So here's what I'm going to do. I'm going to draw out like in just a bulleted list what the hierarchy is, with the thing at the top of the list being the base. And looking over all these things, we can think about like what is the common thing amongst all these, and these are all considered weapons, right? So weapon here is going to be our common one. In addition, under a weapon we have what are the next level past that. We're not looking at like magical sword or sword of 1,000 truths. We're looking at more like generic things, right? We got like a stabbing weapon, and then I see like a blunt weapon. Okay, so we can do stabbing weapons. Blunt weapon. So these two things are good, right? And then under stabbing weapon, there's a few things that live under there. There's, I see sword, I see spear, I see broadsword. But the broadsword doesn't belong here, right? Because the broadsword is a type of sword. Yeah, so you go with that under there. Spear is okay. Falchion is also another type of this. Let me just cross these out. Spear. Let me do mace here. Mace would be a blunt weapon, right? Same with a hammer. What about warhammer? Probably a type of, right? And then falchion here we have, broadsword we have. So we have these three remaining. And Sword of 1,000 Truths is a type of sword, but you know what? Like you can kind of interpret this your own way, and this is where it starts to get interesting. If I said broadsword of 1,000 Truths, I think it'd be really obvious it'd be under here. But because it's not necessarily clear, you could put it under here. You could put sword of 1,000 Truths here. I think it actually would be okay as well to put this guy as well under broadsword. Or, yeah, so what you see here is there's another type of sword called a magical sword, which is a type of sword that's not necessarily a broadsword or a falchion. And that is where Sword of 1,000 Truths really could go, and I think fits a lot better. And this thought process of figuring out where things go is kind of the thought process you kind of need to think about when you're making games in general, like any kind of game, is I have this thing in my game. I have like a bullet in my game, right? What hierarchy would the bullet fall under for my game? Or like I have a thing like an explosion that occurs, right? Where does that go in my game? Or a player, or an asteroid. Or if you're thinking about like Overwatch, where does a hero go in the hierarchy? And a bow and arrow would also go. Because it's a type of weapon, but it's not blunt or stabbing. So this is kind of what I was looking for here, a hierarchy like this. And a lot of this is also like breaking down something into smaller pieces. Like if I just asked you to say, hey, let's say I have a weapon here, and I didn't have any of this stuff declared, right? And I asked you guys to say, hey, what about a bastard sword? Describe to me there is a relationship for a bastard sword in your game. Like, I want you to come up with what that hierarchy looks like without me showing you what kind of things exist. Like, I want you to say, okay, what would the base class of bastard sword be, right? What would you put here? And you have to think about, well, a bastard sword is kind of a two-handed sword, right? You break that down. What is a two-handed sword type of? Maybe a sword, right? And swords are a type of weapon. And what are weapons? Equipment. And what are equipment? What's above equipment? An item. What about above an item? There's usually one. It's something generic, something like an object. Usually like game object. And this kind of hierarchy here is when I say just figure out a hierarchy for bastard swords, I want you to think about this process here about, okay, well, I want to be able to describe things in my game in this way. Sometimes it's not as deep as this, right? Like if I say, let's describe what an asteroid is for the asteroids game, or let's do this. Let's think about this in terms of a video game for asteroids. An asteroid is a type of what? It's kind of weird because you're thinking backwards, but this is the mental gymnastics that you have to do to be able to like structure a game. Collidable? Sure. There's no wrong way to like start with this. This is a movable object too. And maybe there's one more, which is just a game object. Other things that are collidable would be things like a UFO. Movable here would be like player, or maybe player is under collidable. Like this, right? Other things that are movable but not collidable maybe are like particle effects, or like explosions. Bullets are collidable though. Yeah, they have to collide with something, right? Other things that are game objects that are not movable, maybe like UI. Or what are other things like the background? Sound, sure. Other things that are movable. I have the UFO in here.
What if there's like a trail for the player?
That's kind of could be under here. I don't know if there's actually anything else in asteroids other than these things. But this relationship here is kind of what I want you guys to think about for classes. This is, if I just start writing this in C# or C++, I said C#, I did not mean that. UI would be class UI, which extends off of game object, right? That's what that looks like here. Get this, okay. So that's what the class declaration for UI would be here. And then if I do a class for movable, right? Something goes under movable as well. We have collidable, right? That's what we have here. Okay. That's all this relationship is what is this? What is the base class of collidable? We know that it's movable here. And then what the player becomes is player is just base class of collidable, right? And the reason why we do this, the reason why it's actually important to describe this hierarchy is because we're not just describing like an order of what things are, it's also describing what these things do. Because the trick in object-oriented programming is, let's say I write some code to move objects in my game. Well, I'm going to put that here in my class for movable. And because a collidable and player objects are essentially children of movable, these two classes also are considered movable, which means they will also move in my game if I give them some velocity. Anything that I write for being collidable as well means that anything that derives off collidable, which means the player, UFO, and bullets, are also considered collidable. So I write that code once for the base class here, and now all of a sudden players, bullets, and asteroids, as long as I derive from this base class, are now considered collidable and have all that behavior in them. So they also will collide in the game and have the proper behavior. I only have to write that code once, and I can make a dozen different types of collidable classes, and they all behave exactly the same way. Like they have everything that I wrote once, and they work correctly. And I'm guaranteed that they work correctly because they are derived from this class. And they all move correctly as well. And anything that I put inside here, inside game object, will be shared across all of these things. So if I wanted to do something like, say, hey, have the ability to like hide a game object here and stop it from rendering, I could put that here in the game object class. And now everything in my game has the ability to be hidden just by deriving from it. I don't have to write any extra code. Literally, this line right here gives me everything that the game object has, right? Same thing here. This line gives me everything that collidable has. It's just one little thing right here will make it so that everything is reusable. It's a really powerful concept because it lets you write something once and reuse it a whole bunch of times, right? Unreal has a really classic example where all of their objects are derived off something called, there's an object, and then there's something called an actor. which derives off object. And then from actor, there's something called a pawn, which derives off actor. And then from pawn, there's something called a vehicle, which derives off pawn. Then they have something called a flying vehicle, which derives off that. So they have all this behavior. A pawn, in their case, is something that can move with player input. And that means that a vehicle can move with player input. And a vehicle is something that is driven by physics. So a flying vehicle is also driven by physics, but this has special things that make it unique in that it can actually go up in the air. So now it has controls on top of the existing controls. It has the ability to go up and down, which is not something vehicles normally have. All right? So we're going to use these concepts to make asteroids, and our asteroids class hierarchy is going to look more like, it's going to actually be quite simple. We're going to have probably going to do this as our hierarchy. And what we're going to do is we're going to put all the movement behavior and collision behavior in one of these classes, just to keep it a little simple, just so that we don't have to manage so many different classes. Although, to be fair, you can break it apart if you want to into more. At this point, I will say there is, I have to do this caveat because I'm teaching you guys how to do all this class stuff, and this stuff is really powerful and really important to learn. There is a trend, it's okay. There actually, in the past like decade or 20 years or so, this used to be kind of like the way you made games, just like how in Unreal there's actor, pawn, vehicle, flying vehicle, and from pawn there's like bots, and there's like a redeemer rocket which you can control, that's a pawn. And recently though, a lot of game companies have been talking about simplifying this relationship. So instead of having a relationship like this, they're talking about flattening that relationship instead of going like really deep. Changing the way you think about how game objects are represented. Instead of a game object being a player and a player having all the properties of a game object, so what Overwatch does, this is kind of an advanced topic, but I do want to mention it because I think it's important to know that a lot of modern games are also doing things a little differently. So in Overwatch, for instance, our hero is made up of, is derived off one thing. We actually don't have, we have one thing which is called an entity. And an entity is basically anything in the world that exists. Like anything that is that you can basically see in the world. Sometimes even things that you can't see in the world are considered entities. So like managing our UI, we have entities that do that. However, we have a hero, and you would think like a hero or like a weapon would be a type of entity, right? The reality is that we don't have these as explicit classes. What we do instead is an entity consists of multiple components that belong to it. And what we do is we describe an entity by the things that it has, the properties that it has. So for instance, a hero has a lot of things, like he has health, he has movement, he has a network connection, he has an effect, he has local player behavior, he has, what other things does a player have? We have something called stage script, which is our kind of like our blueprint version of designing things. And so these define kind of what a player is. And these are each separate classes here. And what we do is we do it a little differently. Instead of having a class for hero that derives from all of these, we instead flip it around and we say, well, these don't derive from anything, really. They derive from one thing, which is called a component, but that's it. And these just are components that each are added to the hero, and that describes what a hero is. And this is different because we might have something like a breakable vase. And a breakable vase has a health, and a breakable component, and that's it. Maybe a little bit more than that, but this is pretty much it. But it shares the health component here, but it has its own breakable component. We have things like a door in our game, which has a static component, an animation component, and a network component. Potentially, this gets added. So a door is made up of these three things, right? So you kind of flip that relationship around, and this is what we use in Overwatch. This is considered a component system. The technical term that we use is called ECS, which stands for Entity Component System.
So would health and movement and all that be kind of like a class that you just pull from?
Yeah, so the way we have it, we have a class for component, which is very, very silly. It's very small, does almost nothing. Then we have class health component, which derives off that.
Okay.
And that's it. That is as deep as we go. Nothing derives from here. Nothing. We don't have like a super health component that derives off health or anything like that. There's no such thing. And there's two parts to making this thing work. I'm not going to go into too much of details. If you're curious, you should look this up, the entity component system. This is kind of like the new wave of like doing things, because Unreal still does it this way. And there are issues with using hierarchies like this. However, for this class and for the rest of your time here, there's no problem with you guys using object-oriented programming like this, because this is actually still like totally valid for the games that we're making. This right here is slightly more complex, and to really understand the benefits of this, you really have to have gone through some of the pain of doing stuff like this, or also like made a few games of your own using classes, because then it becomes a lot easier to understand. But the reason why this is becoming more popular is, one, it allows you to break apart your behavior a lot more discreetly. You can have like separate pieces of behavior and then just add them to the entity. Whenever you want to add new behavior, you don't have to like touch the entity. You just say like, oh, we'll make a new component and just add it. And that'll give that behavior to the entity. And also, it's a lot faster and a lot more, I want to use deterministic as the word, but it's a lot more easily understood how multiple components interact with each other. One of the classic problems typically games have is, I have all these components on a hero in Overwatch, maybe animation is another one. Each one of these things has to have a chance to tick. Each one of these things has to have a chance to update itself. How does health update in relation to movement, in relation to animation? A lot of times you have dependencies. Like we have something, you might push a button, right, that causes an animation to play. So if you push a button here, like this goes in the order that it gets updated, you won't actually get that animation until the next time through. So you want to make sure that all of your buttons for all of your heroes are handled at the same time. Whereas right now in Unreal, the way that they update is they update every entity. Each entity gets one pass. So each entity gets to update their health, then their movement, then their network connection. But for Overwatch, we update all health components across everything all at once. So this is important because you will have to know like kind of this stuff. I think this is kind of the trend that everyone is going towards, is this ECS system. Unreal isn't using it yet, but they have they do have a component system, but it's not in their like base level engine. They still have a concept of actors and pawns and stuff, and they use components on top of that. But yeah, I thought this was really cool. I think this is just a really neat way to do things. I know there's a lot of like stuff there that like might not make sense yet, because some of that is actually kind of nuanced, even for a lot of people that we like. For me, this is the first time working with ECS on Overwatch. Like all my past experiences have been using class hierarchies like this. So I think it's very once we started like talking about it and using it and understanding how it's supposed to be used, it really made the development of our game much easier. I think I attribute that to one of the reasons why we're able to make the game so fast too. Okay, and then let's talk about this real quick. So we'll do this final thing here. I'm going to describe the hierarchy here for an RPG class. And we're trying to find the base class for this thing. And I'm looking here, I don't really see any base classes. So what we're going to do here is we're going to make something called a class. And this is going to be the base hierarchy for this. And under class is going to be all the things that I can see, like ranged here, caster is another one. And then we can talk about where the rest of these things fit. And this is a little bit more of a straightforward thing, but these classes belong under the class base. So I think like warrior probably belongs under melee. These guys here probably belong under caster, right? Paladin also probably under melee. We're going to talk about that in just a second here. archer, master archer. Arch black mage. Fury warrior. Yeah, Microsoft bullets are. Everyone struggles with them. And then Uther Lightbringer, which is a type of paladin. So I want to talk because paladin is kind of an interesting piece here, where paladin is kind of a melee class, but it's also kind of a caster. So in a lot of games, a paladin both has the ability to do melee damage and also cast some spells that are available to white mages. And there's a couple ways to solve this. This is kind of an interesting problem. One way to solve this problem is by using ECS. So if you actually use ECS, you don't have this issue because you would have a component for casting spells, you'd have a component for doing melee damage. But in the world of object-oriented programming where you don't use ECS, you have this issue. This is one, I'm highlighting one of the problems that you get with inheritance, where this paladin can only belong really under one tree, right? He can only really either be a melee or a caster. So how do you break this apart? And it gets to be really tricky. There's not really a very clean way to do it, but let me show you a couple of ways you can work around it. One thing is you can make something here that is casters can be considered melee. It's kind of weird, but you could do this. And once you do this, you can make a paladin a type of caster because he's also a type of melee. So if you look at this relationship now, I have, if I created this, I could create caster off melee, which feels weird. But if I do this, now I guess I get paladin, which is a caster and a melee. The downside is that now white mages and black mages and red mages are also considered melee. So I get this weird problem where it's inheriting both a caster and melee, and I don't get to have separation as clean as I want to. You can also flip this if you wanted to. So you could put caster here, and melee are types of casters. And you have a very similar problem, though, where now these, instead of being under melee, are casters correctly, like so. But now your melee warrior is a type of caster. So you have this weird issue where you have to basically have this hierarchy include one of these two. It's kind of a catch-22 situation. This is one of the problems with classes where you might be trying to describe a relationship, but the way you've broken apart your objects, you can't actually describe it accurately enough. There are a couple other ways you can resolve this. So the way that I described is kind of one way. You roll up all the caster behavior into the melee class and you make them the same essentially, melee or caster, like this. And this gets to be really weird because now you have a class that's one or the other. There is also a concept in C++ called multiple inheritance, and I really hesitate talking about it because most of the time it only really leads to a lot of confusion and complication, but there is a way you can make something that is a child of two different things. So if I had melee here and caster here, typically you have to pick one or the other as the child. So I have my paladin here. But there is a way in C++ to have a paladin also derive from caster at the same time. This is actually kind of not really great. The reason why is that now you're actually both inheriting everything a melee guy has and everything a caster guy has, but you might have put stuff in caster that is the same as in melee. Like casters might have something like HP, right? Or might have something like equipment that they have. And you start getting into conflicts between these two when you inherit from both of them that you have to resolve. In addition, typically we don't really allow multiple inheritance with a very few exceptions, like in Overwatch at least. So most of the time, this right here, this problem with trying to describe a hero that has two different sets of properties is exactly what ECS is trying to solve. Okay? Understanding how to create this relationship. And I want to talk about this because in ECS, here's what you would do. You would have an entity for a paladin. He would have a casting component. He would have a melee component. And he would have a class component. while a white mage would just have a casting component and a class component. And describing it like this lets you do whatever you want to. Like this is basically a paladin. And what's nice is that you can make something that's even a mix of all three, right? You could have like, what do they have, those rangers? They can melee, they can use ranged attack. They can also cast. They can cast spells, right? I think Drizzt was a ranger in the D&D book series. Yeah, so they can do all three. And you don't have to have a hierarchy that describes it. Literally, they just are made up of whatever pieces. Think of these components like pieces of equipment you can have on your character, and they give you what behavior you need. Okay. I know I went over a lot, but this right here is what we're going to be doing for the rest of the quarter. All right? Questions? This stuff? This is like the new hotness right now. Like, we're probably going to talk about this at GDC. I don't know. I would love to have us talk about this. I keep pushing us to talk about this at GDC, but
It's like the flow is reversed.
yeah, exactly. It's flipping it around. So instead of having a really deep hierarchy, you have a flat hierarchy like this, and then you work with that. All right, and then the third one, shapes and area. We kind of actually already did this. We did part of this in class, which was to describe what a circle is. I actually gave you guys a link to a website here. If you guys were having trouble, there's actually a link here.
Look it under polymorph.
Yeah, it's here. This website here actually describes exactly kind of the way you set up the three different rectangle, circle. Actually, I don't know if they go over a circle.
No, they don't go over circle.
Yeah, so what's nice here is that if you want to have more reference, you can always go to this site. I actually link up here to the C++ tutorial. I'm going to go over this real fast, though, just so everyone has an understanding of how this thing works. The general idea is I want to have three classes, circle, rectangle, and triangle, and each one has an area function that's overridden, right? And the hierarchy for that, if I go back to this document here, would be shape, right? Then we have circle, triangle, rectangle. And that's the hierarchy we're going to make here. And shape has a member inside of it that's called area. And each one of these also has the same member, and they override this function. That's the goal. And because each one of these overrides this area, each one of these handles how to return the area differently, because the way you calculate area is different for each one of these, right? Okay, let's do this. So we're going to do this here. So first things first, so you got to make a class for a shape. It has a virtual function. We're going to make it under the public scope. It has a virtual int area. Returns a float. And I'm just going to have it return 0 by default, because if I don't have a shape, if I'm just using a shape, there is no area, there's no member variables inside of here. So we start with a circle, which derives from shape. And a circle has a few things. One, it also has an area function. And it's going to return, I said area, right? Not circumference. Yeah. Pi times radius. And radius is a member variable that lives inside of circle. So because it's a member variable and because I mentioned that I want member variables to be private, I'm just going to declare it here. I also asked you guys to make a constructor that takes a float for the radius. And all this constructor is going to do is just going to assign its member to be the argument that's passed in. So this member variable is this guy right here. It's the one that's highlighted. And the key is that I want to have a pointer to a shape, and I want to create a circle for a radius of 25 and print out its area. Okay. So I'm going to create a pointer to shape. It's going to be equal to a new circle with a radius of 25, and then I'm just going to do a cout and uncall the area function on the circle. Now, this shape is a pointer to a shape. However, its property call returning 1963.44. And this is because it's actually pointing to a circle. Even though the pointer actually says it's a shape, it doesn't care what's inside of it, it just says it's a circle. So what happens though if I remove the virtual keyword in front of here? It actually means that it won't try to figure out which area function to call at all. It's actually just going to call the area function that it knows, which is a shape. It's going to statically determine what that is, so that returns 0. I could have it return something else here just to prove. If I have it return 42, it returns 42. The reason why this happens is because even though I have a shape pointing to a circle, when I go to call this function area on it, it says, oh, well, I have two ways to figure out what function I should call. The first way is, hey, determine when I compile this program, and when I compile this program, if it doesn't have virtual in front of it, I'm just going to call this guy here. If you have a virtual in front of it and it goes to compile and figure out which of the functions to call, it's going to say, well, this thing is dynamic. It's going to dynamically determine which function to call. So I'm not going to actually figure it out until I actually run that line of code, which means when it gets down to here, it's going to figure out, oh, well, even though it looked like a shape, inside of this pointer is actually a circle. So I'm going to call the circle version of area. And that's what virtual does, just as a recap. So we have a circle, a triangle, and a rectangle. So these are all kind of the same, except a triangle takes a width and a height. So I'm going to do that here. Create a new class for a triangle. It's going to take a width and a height. It's going to have two members in it, width and a height. And to figure out the area of a triangle, it's 1/2 times the base times the height. And we just have to set the width equal to the width, like so. And then for a rectangle, let's make the rectangle next. Rectangle is very similar to a triangle in that it has a width and height. However, the area is just width times height. And now what I can do is I can create a shape variable using the same exact shape variable. Not declaring again. I'm going to create a new triangle here with base of, what did I say? 50, height of 50 and a width of 10. Call the same exact function. And then rectangle, like I'm literally only changing this line here with a height of 100. So the same exact line of code is being used for each one. However, it's going to give me 3 different ways to calculate area based on the shape that's given. Okay? So triangle, and then rectangle, and circle. Okay. I know that shapes and stuff is only mildly interesting because, like, oh, yeah, it's all text. But the same idea is going to be used for things like, oh, well, I have a bunch of different weapons in my game. And maybe each weapon that I have is a different class. And when I ask the weapon, hey, how much damage should you do, it's completely dependent upon the weapon itself. Like some weapons do a more random range damage. Some weapons do a little bit closer range of damage. Some weapons do more damage the closer you are to the target or further from the target, right? And all of those things should be using something like this where it's one function to get the damage. However, when you get and write the function, it changes what actually returns based on the class that you defined it in. So maybe I have like a melee weapon that does a lot of damage if I'm close. Or I have like a bow and arrow which does almost nothing when I'm really close. I don't know. But the idea remains the same, where you would have a virtual base here, and then you would actually derive it. Okay, questions?
Would you use delete after each time you...
Yeah, so you should do that. I didn't ask you to do that, but as part of the, oh, I do actually ask you to do that. Yeah, you should actually, yeah, because normally you do that because whenever you declare a new, you want to follow up with a delete. In the case of this program here, like you only run it and then end it. like right away, so these pointers won't stick around. But you're right, this should be using delete here. And you just call it delete on this each one right before. Like so. And so what's interesting is that you can do something. I'll just show one more example here just to demonstrate. I'm going to include this and include time. We're going to do a random time. We're going to do randomly generating shapes. And I'm just going to say while true, I'm just going to make a loop here. And what we're going to do is I'm going to randomly choose one of these shapes. And one of them is going to be a triangle. One of them is going to be a rectangle. So I'm only going to call this function once. However, every time through this loop, it's going to randomly pick one of these things to create, which means it's going to just consistently spit out like different shapes of things. Some of these things, it's actually hard to tell. I'm going to actually print out the area here. I'm going to standard cout triangle. And I'm going to do here circle. I'm going to do here rectangle. And this concept here of randomly generating something like this maybe could be used for like inventory, right? Like you want to give a random inventory item based on what's dropped. And so see here how on the left I have circles and triangles and rectangles. It's just randomly kind of picking one. But it's calculating the area for each one differently based on the item that's in there, right?
Hey Keith,
Yeah.
on the numbers that we're just printing, why at the end of it did it say like E plus?
Yeah, so if some of those things are really, really big numbers, like in the case where it has to use numbers that go outside the bounds of like what it can display, so it actually is multiplying them by, like that's scientific notation. So it just means that the values that it's trying to print is too big. So here, like circle, that's 1 to the 6th power, 1 times 10 to the 6th.
Okay.
It's just making it so it can fit on screen. Because some of these numbers are actually quite big. It's actually could be like 600 times 600.
Is that generally like bad though? Should we try to avoid having results like that?
No, you can change the formatting here. There's a way you could format the actual output here. When I do this, you can format to say, hey, always print out the full length of the number, even if you don't want if you don't want scientific notation. Or you can also say to only print out up to 2 decimal places worth. Which we've actually done before. Remember when we did the set W, like 10?
Yeah.
You can also do, I believe it's like IO set precision. There's like a set precision call, which lets you say like how many decimal places you want to actually show.
Okay.
I think that's in here. So like here, you include this header, and you can say like, oh, well, I have this number here that's pi, set precision 5959, and you'll get like these outputs here. If you say like, oh, precision 9, or this one actually, notice how it says only do five significant digits. So you can say, oh, well, it'll actually round up that 59 into 16, right?
Okay.
And if you want to set, if you set the to be fixed, it'll add zeros on the end of it if you want. So you can control the output that way too. All right, so let's talk about classes. So I'm going to put, actually going to collect the homework now. So if you haven't already put your homework in there, please do, into SDVA213. I'm going to put a copy of the engine we're going to use today as well.
So what files do you want?
I want the CPP files that you did for 1 and 3, as well as the Word document that you did for the is a experiment.
I gave you the one you
Wait. You didn't do number 2?
Yeah,
Okay.
I didn't know that it was that question.
Yeah.
I didn't know that either.
Well, give me what you have, and I'll look over this. I'm gonna look over this while you guys are doing your lab. So I only have 5 right now. Who else is missing? 6? Dom, you missing? Okay. Yeah. Let me take all this. All right, so grab a copy of this engine because we're going to be using it for lab today. It's from Zool. It's in 213. Make sure it opens up locally and you run it, and it should show you a green circle.
Don't open it from the folder.
You do not open it from the folder, good God.
AJ.
You know what you did. Actually, to be fair, I almost did that just now, too.
Did you already collect one?
Yeah, I just did. If you have it, just hand it in right now, and then I'll collect it. Let me know that you did.
Okay, I'll just
Yeah, just drop it in there. I'll grab it. Yeah, just make sure you run it and it looks like this. Green circle.
It's not really the best computer to be using that thing full screen.
Does it?
Or it used to. Unless I fix it finally. Didn't fix it for like
Did
4
you get
quarters.
the, is it the software?
I'm pretty sure this isn't a blue screen. I think it just goes to a black screen.
That's
right?
what I
It
just
skips
said,
the
that's
whole
what I
blue
got
screen
last
process.
time. Before I started copy.
Mouse?
Yeah, there's the cockpit. Look.
There's probably a lot of files.
Ah.
Take a file, open up for everyone. These folks turn in the lab and the lab 1 and
Are you
lab
canceling or are
3.
you copying?
AJ, you
There we go.
It's stuck.
There you are. I just see the big ass head.
Mine died.
You died while copying.
Yeah,
Just do it again.
keeps getting stuck on 10 seconds. And I click cancel and it's now saying 2 minutes 15 seconds.
I'm remaining 23 hours to report.
Oh, seriously?
That's what I said.
Only 23 hours?
Only 23 hours.
Who actually got the copy in?
I got it.
Okay.
I
Okay.
think so.
All right. The rest of you can go home. It's fine.
We've been having a lot of issues lately, no, honestly.
Personal program.
Well, easy updates for 4 years. But they never clear the shit out.
I think it's because they fired everybody. Now they're looking for new techs. Yeah.
Payless.
Yeah.
I think at this point, like almost any like $200 off-the-shelf PC would be faster than these things. This is. They probably run more games too.
Why? Why turn in lab 1?
Here, I can copy. I can copy to a different location on Zool too. Maybe that will help.
Shit, my team. Straight up. 5 seconds remaining. That should stop midway.
I'm probably making the problem much worse. Okay, so I just copied it literally to the root of Zool under SDVA engine. So if you want to grab that, might be faster. I don't know. I also have a USB drive I can hand around.
Just bouncing around.
I want to take a toke and then.
Apparently so, bro.
Remember when we did that for the Halo demo in school? So when I have the Halo demo on the USB, and they just installed it on every single computer. It's
Yeah.
amazing.
Everybody been playing it. Because the demo was free to play multiplayer.
Yeah, a little LAN.
No land.
Yeah. And so we have.
All right, who needs it? I have a copy of it on USB. Just this stuff.
Definitely stuff. But, oh, access denied.
Someone's running it. Someone must be running it from the network. That's the only answer.
Yeah.
Yeah, AJ.
I know it's you, AJ.
I'm working it off the desktop.
Just asking.
Somebody check
That's
his
not
monitor.
the USB drive. That's your USB drive. I think. Oh, that must be a DVD or something in there.
Has to be. Nope.
That's really fucked up.
Did you make it bootable?
Yeah, it had a Windows installer on it, but I just literally copied it.
Technology.
Yeah, did you grab the one off the root of Zool instead of grabbing this one?
No, I tried to grab that one, but
Yeah, just cancel
this
this
is
one.
before they won't even cancel.
Don't, yeah, just put that to the side and then copy that. Get a new one off the root of Zool. Yeah, get that one. Then when you had selected right there.
Wait, yep, went straight to Google again.
Can you click on it and say? That's
I just confused.
Give me the USB drive. Let me see.
See, that one will actually work.
Okay, yeah,
One
just
from
copy the one off the root of
the
Zool.
root copy.
Yeah. Grab the one off the root of Zool now. Let's see why this one starting up as a bootable.
And
Maybe you watch it. I don't know. During leg on. Oh, I've actually seen some of that series. It's actually fun.
place.
It's on
For
Oh,
sure.
they're supposed to put a green circle.
even the complete
What's that?
Star Wars saga is in there.
Yep, that's it.
I don't know if it's in there. Really? Because I looked up Zool before.
You got it? It's good. Open it up, make sure it runs, please. Should we take a break before we go?
Yes.
Take a
Yeah.
break? All right,
So
let's
look,
take a break.
It's right here.
Let's take a break. Be back by 9:40. I'll give you guys half an hour.
Like, you